Hi guys, so we're in 5.3, graphs of relations and functions, and the first thing that we're going to be doing is talking about stating domain and range. And there are two different ways that we need to do this depending upon what your graph is, okay? So if we have a graph that is made up of only points that are not connected, there is a specific way to state the domain in the range that's different from when you've got an actual line or some other curve in your graph. Okay, so for example, okay, here is an example of what I'm talking about. Okay. I'm going to put another negative one down here. Okay. Now that is a lot of points, okay? But as you can see, that graph is made up of only points that are not connected. So the rule for stating the domain and the range is that you take the coordinates of each point, x is the domain and y is the range, and we will put them in order from least to greatest, no repeats. Okay, so we'll first state the domain. The domain is all of the x values from left to right, which would put them in order from least to greatest. So starting right there, we are at negative 1, 2, 3, 4, 5. Then the next x value comes from those points right there that are at negative 3. And even though I've got 2 points that are at negative 3, I'm only naming negative 3 once. Remember, no repeats. Then my next value there is at x equals 0. Then the next one is right here at x equals 2. The next one is right here at x equals 3. Then here we've got 5. And then finally 6. Those are all the domain values. Okay? So when we don't have those dots connected to give us an actual graph, a line, or a curve, okay, we state the individual coordinates, x in domain and y in range. Now, range, again, is least to greatest, lowest to highest, no repeats. So the lowest y value starts down here. Okay, so we start at the lowest one and we are going to work our way up. Okay, so the lowest y value is at a coordinate of negative 3. Then the next one is at negative 2. And we're going to keep going up. And here we are at 1. And I've got 2 coordinates at that y value, but I'm only stating that 1 once. Then right up here, I've got a y value of positive 2. Right here, positive 3. And right up there, positive 4. And I'm only stating it once. So the domain and the range for when the points are not connected, you state the coordinates x and y for domain and range. Okay, that is completely different than if your graph is a line or some other curve in the coordinate plane. Okay, so what that would look like would be something like, let's do this curve right here, which is a parabola. Okay, so the domain would be, so the domain would be from the lowest x value to the highest x value, okay? So as this branch here keeps getting bigger and bigger and bigger as far as y, it also will continue to go out and out and out into negative infinity, okay? Likewise, this branch will continue to grow up and up and up and up and up and up and up, and it will also continue out into positive infinity. So the domain is going to be all real numbers, okay? Because it will go from negative infinity to positive infinity, okay? So the domain is all real numbers, okay? Now the range is, remember, the lowest y value to the highest y value. Well, the lowest y value is right there at y equals -1. And from -1 right there, from that -1 point right there, the graph just keeps on growing forever. So -1 is less than or equal to y, which is less than infinity, which in general, what we would say is that y is greater than or equal to -1. Okay, notice there is no way in the world that we are going to be able to name every single point on that graph like we did here, okay? There were just single points there. Very simple to name each xy coordinate. But if you look at this graph here, this graph is actually made up of a billion, trillion, gazillion points that are so close to each other, there are no spaces in between, okay? And because it's not possible to name all the xy coordinates from each one of these little tiny itty bitty yellow points on this graph, we have to resort to just the lowest to the highest as far as domain and range, okay? So we're going to do another graph, okay? Domain and range. Now what we're going to do is look at something like that graph. Because of the arrows, we know that it will forever go that way and it will forever go that way. Okay, now domain. Domain represent the x values, okay? The lowest x value to the highest x value. Remember, these are your x values right here, okay? These are your x values. The lowest x value, when you read from left to right, you read a graph just like you read a book, left to right, this is the lowest x value going that way. That x value is 0, okay? That x value is 0, and as far as the arrows go, they will go forever down and up, but they will also forever and ever go out into positive infinity. So the domain would be 0 to positive infinity, but we will write that as, okay, x is greater than or equal to 0. 0 is included because of that little equality sign there. And then it will continue to grow forever. Okay, so we're not learning yet interval notation. So for now, we'll use the equality for stating domain and range. Okay, so the domain is x is greater than or equal to 0. Now the range, those are our y values from lowest to highest. Well, again, these arrows here indicate that this branch right here is going to go down forever into negative infinity, and this other branch here is going to go up forever to positive infinity. So the range coming in from negative infinity all the way to positive infinity is all real numbers. Okay? Now we'll do another type of a graph. Okay. Okay, that's supposed to be a straight line. Okay. Domain, again, is the lowest x value to the lowest, or to the highest x value, and the range is the lowest y value to the highest y value. So domain is a left to right thing. Okay. So the lowest x value is this one right here, x value, not y, x. And that x is at -2, okay? And the highest x value is at 2, 4, 6, 8, 10, 12, is at 13, okay? So the lowest x value is at -2 included, and the highest is at 13, not included, okay? So domain is x, and it's greater than or equal to -2 because that hole is filled in. That's why it's a greater than or equal to, okay? Actually, that's a less than or equal to symbol, but x is greater. If -2 is less than or equal to x, x is greater than or equal to -2. Okay. So x is greater than or equal to -2, but less than 13. Okay. So the lowest x value to the highest x value. And of course, all the points in between. Okay. Now the range. The range will start from the lowest y value up to the highest y value. So for our graph right here, that is the lowest y value, and this one up here is the highest y value. So this y value down here is at -3. That is the low y. Up here, the highest y value is a +3. So the lowest y value is -3. The highest y value is +3. Range is represented by y. Okay? So at -3, the hole is open. At +3, the hole is closed. Okay? So again, we are stating just the low and the high, implying that everything else in between, all the numbers in between -2 and 13 are also included. We are also implying that all the numbers between -3 and +3 are also included. But there's no way you can name all of them. Because it's not just -2, -1, 0, 1, 2, 3, etc. You've got -2, then you've got, say, -1.999, then -1.99, then -1.9, then -2, okay? So then you've got tons of decimal places in between there, okay? So if I were to ask you how many numbers are there between 0 and 1, You've got an infinite number of numbers between 0 and 1. That's why it's impossible to name all of the numbers on that graph. Just you'll be dead before you even get a millimeter down that graph from one side to the other. Okay? So now we are going to do some graphing and then stating domain and range. So we're going to graph in example 4. It looks like this. D equals, and then you got a pretty bracket with x, y. So they really, 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 really like to make things look super difficult and extremely confusing, okay, by writing the equations in this form. Okay, what that says is the graph D, okay, that's just what they're calling this graph. Graph the coordinates x and y such that y is equal to plus or minus the square root of x when x is equal to 1, 4, and 9. Okay, so let's make a table. X, and we're going to put our plus and minus right there, and then y. Okay, so we'll do 1, 1, 4, 4, 9, 9. Okay, so when you plug in well, you're going to plug in ones, but so the square root of 1. Okay, x is a 1. Okay, so the square root of 1, and we'll do that positive, and then we'll do the negative. The square root of 1 is 1, positive. The square root of 1 is 1, negative. Okay, the square root of 4, positive, is 2, and the square root of 4, negative, is negative 2. Okay, the square root of 9 when it's positive is 3, and the square root of 9 when it's negative is negative 3. Okay, now we can graph. It just says make a table to find the ordered pairs and then graph the ordered pairs. Okay, so we will plot those coordinates. Okay, when x is 1, y is 1. And when x is 1, y is also negative 1. When x is 4, y is 2 and negative 2. When x is 9, y is 3 and negative 3. Okay? So those are the dots that make up that graph. Okay? So the domain are all the x values in order from least to greatest. 1, 4, 9. Okay? Even though we've got 2 x values of 1, 2 x values at 4, and 2 x values at 9. We are only stating with no repeats, okay? So obviously, because x is repeated, this is not a function. Okay? Then we can also state the domain or the range. Okay? No repeats. The lowest y value is down here at negative 3. Then we jump up to negative 2. Then negative 1. Then positive 1. Positive 2, and positive 3. Okay? And it is not a function because it shares x values. It doesn't matter if it shares y values, but it does matter if it shares x values, and it does. It shares 1, 4, and 9. Okay? All right, so now we're graphing the function y equals negative x squared. Okay? Notice in this particular case, we are not given a domain that we need to plug in. In other words, the last equation gave us x values. This equation does not. We're just graphing this, and all numbers, any numbers, are allowed. Okay, so we'll plug in some values of x into negative x squared and get a y value. Okay, so let's use negative 2, negative 1, 0, 1, and 2. Okay, so we already have a negative there. What we're plugging in, a negative 2. So let's write all of these out. And then we'll do the math on these and get our y values. Okay? So, negative 2 squared, remember by the rules of operations, orders of operations, exponents will come first. Okay? So negative 2 times negative 2 is positive 4 made negative. Okay? Likewise, negative 1 times negative 1 is a positive 1 made negative. 0 squared is 0 made negative, which is not even a thing. 1 squared is 1 made negative. 2 squared is 4 made negative. Okay? So we'll plot those points. Negative 2, negative 4 is right here. Negative 1, negative 1. Then 0, 0. Then 1, negative 1. And 2, negative 4. And that is an upside down parabola, which will go down forever, okay? And then domain and range, okay? Domain, as it continues to go down here forever on each branch, it will also get farther to the right forever and farther to the left forever. The domain of any parabola, whether it's right side up or upside down, the domain is always all real numbers. The range will go from the highest to the, or from the lowest to the highest value of y. Okay? So the lowest value of y, somewhere down here. Well, those arrows indicate that the branches will keep going down forever into negative infinity. So that is the lowest value of y, okay? And then it will go up to the highest value of y, which is right here. The highest value of y, which is the x-axis, which is the same thing as y equals 0, okay? So when we write that in inequality form, range is y is less than or equal to 0. So any number of y less than or equal to 0 is included on that graph. And of course, all these values of y here are less than 0, right? Because they are below the x-axis where y is equal to 0. Okay? So stating domain and range is probably going to be the most difficult part of this whole entire chapter. Getting used to how to state the domain when you've got graphs and how to state the domain when you've just got dots. Okay? All right. Awesome.